Hello, everyone. Welcome back. I'm actually going to turn off the lights here. So, a couple things. So, our first exam is open now, and we do Friday. Why did that go? Oh, there we go. So it opens up already. I suggest waiting until after today. So, like, because today is basically kind of a review day, just kind of utilizing everything you've learned from Unit 1. And a couple things though, I realized that the amount of material that was especially since we're going to be doing some practice problems that will help us with sections 1.5, 1.6, I decided to extend those due dates. I had meant to do it a lot earlier, but I didn't press basically I just didn't press submit in essence. So I'm sorry about that. They are now extended until this Sunday. So sections 1.5 and 1.6 homework and quizzes are extended until this Sunday. I recommend doing them before you take the exam because that's free practice. If you haven't already. Sorry about that once again. Yes.
So Wednesday is also a review, or no? Wednesday we're starting new material?
Wednesday we'll be starting new material. Yes, we'll be starting up chapter 2 on Wednesday. So, any other questions? Okay, so let's see here. Is there anything else I wanted to mention? So just remember, with regards to the exam, you get 3 attempts at it. So your best score is the one that's kept. So study up, take it. If you're unhappy, study like try and look through your answers. It might be that there was an easy typo that should be full credit, or a situation where you can get at least some partial credit back. And if not, then you can see what you did wrong and then take it again, knowing fully well that even if you do worse on the second attempt, your best score is the one that's always kept. So
How many questions are on the exam?
3,000, I think. No. I think 10 questions, if memory serves. But it's doable within the time allowed. That's the main thing to keep in mind. Okay. Any other questions? All right. So I brought these problems because I think a lot of them try and tie together basically everything that we've done. So a running track is created by taking a rectangle with dimensions 50 by 30 meters and adjoining 2 half circles to the sides. The picture is shown below. Usain Bolt can run 100 meters in 9.58 seconds. I had to look that up. That was his record. But let's just assume that he can do that every time. How long would it take him to complete 1 lap of this track? So, and then I don't know if you noticed at the very top, it says for all of these things, round to the nearest hundredth, so round to 2 decimal places, and then we need the approximation that pi is 3.14. All these things. So, what's the first thing I should do? Find the perimeter. Yeah, because unless I know the perimeter, I won't be able to find out how far Usain needs to run. So, notice that there's the only dimensions that are given are the 30 dimension, the 30 and the 50. So I know what this measurement is then. So I'm going to just, you guys have all got that piece of paper in front of you, right? So like, it's okay if I scroll down to work on this problem. I'm going to copy this though. So my goal with today is to kind of go through all these problems. Is like, I don't know how long it's going to take us to get through all of them, but hopefully like it takes the whole time class period. But if it ends up being shorter, then we can leave the rest of the time for questions. Otherwise, we'll just go from there. So this one here, paste. So because of those dimensions, we know then that this dimension is 50 meters as well, right? And how do we figure out the half circles? Because there's, oh, go ahead. You can combine them together, yes. So technically speaking, like if I were to draw this circle again. Right? We've got half of it on the right and half of it on the left. So we could just find the circumference of one full circle instead. We could. You could you could do that, or you could break this up into calculating the dimensions of like the perimeter of all these four pieces, like one here, then this piece, then this piece, and then this piece. You could do that, or you could just treat it as two line segments and then a full circle, right? So that's what we're going to do. So I'm going to highlight the half circles. And then those two right there in purple. So the area, or not area, sorry. Perimeter from the purple is just going to be 50 plus 50. So 100 meters. Perimeter from the red is going to be, we have a circle. Does anyone remember the circumference of a circle formula? Pi d or 2 pi r. Now, if we're going to use 2 pi r, we're given the diameter here. We're given the diameter of the circle. We're not given the radius. So it'd be better to use pi d, but you could use 2 pi r. Just make sure that you're making the correction for the radius. But I'm going to use pi d, which we're going to approximate with 3.14 and then times 30, which if I use my calculator, 90.42. 94.2, sorry. All right. So the track is total distance around the track is 100 meters plus 94.2 meters. So that's going to be 194.2 meters. Now, I'm not going to box that in because that isn't my answer. That was the first step. Because we have to remember what the question is asking. It's asking to find how long it would take Usain Bolt to travel across this entire thing. But it told us a unit conversion. It told us that he travels 100 meters in 9.58 seconds. So we can start with our total distance, 194.2 meters times, and he travels 100 meters in 9.58 seconds. So the meters should go in the denominator because we need them cancel. So 100 meters in 9.58 seconds. So the meters cancel and we're left with seconds. Now the problem didn't mention, I realized this after the fact right now, that I should have asked for like how many minutes or I probably should have asked for how many minutes it took. But oh well. So we're just going to do it in seconds though. So the meters cancel. So we're all good. This is going to be 194.2 times 9.58 divided by 100. So that's going to be 18.604. So 18.60436, which approximately is 18.60 or 6, just 6 seconds.
clearly an arrow. Yeah. All right.
Pretty cool. We had to use our knowledge of perimeter, our knowledge of radii and diameter, and then had to bring in unit conversions to figure out the rest. Any questions on that? Yes.
Yeah, can you really quickly walk me through like every, I don't know how to explain, like everything, we did unit conversions, we kind of perimeter.
Mhm.
Did we do anything else? We found the conversions.
So yes, so section 1.5 is circles and composite figures. Now, this is technically a composite figure because it's created by taking two half circles and adjoining them with a rectangle. So in that aspect, we're using section 1.5. And then section 1.3 for unit conversions. For this question, it was just 1.5 and 1.3. Yeah. Now, question 2, hopefully everyone has like nobody came in after the fact and everyone has a sheet, right? Okay, so question 2 says it was determined. So I'm making this up. That's why it's determined is in quotation marks. But it was determined that the best TVs are created when the angle made between the base of the TV and its diagonal are 42 degrees. This isn't real, but just assume that it is. What is the area on a 52-inch flat screen TV? So we have to remember that the measurement for a computer or like for any screen that we get, that is the diagonal. That's right. So let's draw a picture of a TV. It doesn't need to be perfect, right? And then it's got the little legs. And so it tells us, like, so here's the diagonal. And we're talking about a 51-inch or 52-inch flat screen. So this is 52. And then it says that the angle made with the diagonal and the base of the TV is a 42-degree angle. This angle right here is 42 degrees. Okay, and it asks us to find the area. Area of a rectangle should be length times width, but we don't have either of those measurements. Oh no. Impossible. No, it's not impossible. What can we do? SOHCAHTOA, we can use our trig. So let's just call the base. Did not want to do that. X and Y. So X here and Y here. But you can use whatever variable you want, A and B, C and D, cat and dog, whatever. So let's start with X. How would I solve for X? Now, don't say it out loud. Let everyone get a chance to think of which trig function to use, because we've got an angle and we've got a measurement. So think about what trig function you should use if you're trying to find X. All right, what do you think you should use to find X? For X?
So I did the whole, where you flip it, because the top is also X, and the other side is also Y.
Ah, okay. So you
The opposite angle at the top right, the top of the TV would also be 42, correct?
this angle here,
No.
this angle here. So sine for this one would still give you Y. So just to go through this one, So Katoa, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, if we're trying to find x in relation to our I don't know why my pointer went away. In relation to our 42 degree angle, x is our adjacent side. Our opposite side would be y. Because if you draw a line straight out from the angle, that's the opposite side. So we need to deal with the adjacent side. We're trying to solve for x, which is the adjacent side. So that means that sine is out because sine doesn't involve the adjacent side. Yes, it is cosine. And the reason for that is we have the hypotenuse. That is the angle measurement that we do have. So we want the adjacent. We have the hypotenuse. So cosine is the choice to find x, that is. So cosine of 42 degrees is equal to the adjacent, which is x, over the hypotenuse, which is 52. And the way we typically do it, so we're going to plug this into our calculator. Make sure before you take the exam and stuff that your calculator is in degrees. It should be already, but if it's not, you usually see a D at the top of the screen that signifies that. So, but cosine of 42 degrees. I usually like to write about 5 decimal places for this, just to be safe. So 0.74314, that should be good, is equal to x over 52. And then we can cross multiply. Or you can just multiply both sides by 52, but either way, you get that x is equal to 38.64. That's right. 38.64. So this is where we do kind of come into an issue. So technically speaking, this isn't the answer. And we only need to round our answers to 2 decimal places. So hypothetically, it should make more sense to write down as many decimals as we can to get the most accurate measurement, but we should be fine. Especially if you did this on a quiz or an exam and like rounded a little early. If you show me your work, as long as I can see it, I'll give you full credit back because it's the idea is there. Anyways, we'll leave it at 38.64. And then for y is the opposite side, and we have the hypotenuse, so we're going to be using sine. Sine of 42 degrees is equal to y over 52. And so that'll be sine of 42 degrees is 0.66913. So y over 52, once again, cross multiply. And you get that y is equal to 34.79. I guess inches, we should say. And so I'm going to underline those, but those aren't my answer because the question at hand is asking us to find the area, which all we'll do is just multiply these two numbers together because that's the length and the width. So the area will equal the length times the width, which in this case would be, so, I mean, it doesn't matter which one you put first, but 38.64 times 34.79, and that becomes 38.64 times 34.79 is 1344, 1,344.2856. If we're going to round to 2 decimal places, that'll be 1344.29 inches squared.
So
Mhm.
So just a side note, right, I plugged in the whole, like, up to like 6 decimal points, and I got 1344.593.
Yes. So your answer was a little more accurate because you didn't round earlier on. So that would be fine. And like on an exam, if that situation arose, I would give you full credit back. Yes.
I have a question for the quiz, just because you can't like see the actual answer after.
Like, I'll leave it in. Yeah.
Yeah, mine didn't give me the answer, I just saw the
Okay.
So I couldn't see if it was like a little bit off, or so maybe there's something entirely off.
Gotcha. It should do that. Like it might be for after the due date. Let me get back to you on that one. Yeah. Thank you for letting me know. I will check into that. Okay. Let me make a note to myself, excuse me. Three. Thank you. No, that'll repeat every Sunday. I don't want that to repeat every Sunday. That'd be be useless. Okay. Any other questions on this one? All right. Number 3. You are planning on recarpeting this monstrosity of a room. You live in the Winchester Mystery House, apparently. That is a niche joke for for only people who know about the Winchester Mystery House. So, okay, we need to find out. So it says you're recarpeting it. It costs $2.58 per square foot, and it's going to $43.25 per hour for an estimated of 5 hours. So, all right, how do we do this? Okay. What do we need to find first?
The other side.
Very, very good. We need to find the other side lengths because we need to know the area of this thing. Because if we find the area, then we can find out how much it's going to cost in carpet costs, like for raw materials. And technically speaking, also this is going to be an underestimate because it's not like they're going to be really, really accurate. Like they're going to buy more than they need, right? And then they're going to do the snippy stuff, and then so like technically speaking, they probably buy a large rectangle and then just trim it down. But let's just assume that they got this specific exact piece. So we need to know the dimensions. First off, just as a note, this is a quarter circle. So we're going to take the 1/4 of the area on that piece. Now, so let's go ahead and label them just so we have them for record. So this is 10 feet. This is also 5 feet. Now we don't necessarily need to know the length of the arc, because if we were unless it was asking for perimeter, maybe it asks for like the baseboards, at which point then we'd have to do that. But it's not, so we just need to find the area of all the pieces. And for circles, all you need is the radius, right? Pi r squared. And the rectangle, we already have the dimensions of. We have the length and the width. But the triangle, the Pythagorean theorem. But wait, Pythagorean theorem is the right call. But wait, I only have one side.
The side of the triangle is the same as the rectangle.
Exactly. Exactly right. Exactly right. So this right here is also 5 feet. Let's just call this X here. So leg squared plus leg squared is equal to hypotenuse squared. So X squared plus 5 squared is equal to our hypotenuse 8 squared. So that's x squared plus 25 is equal to 64. We need to solve this. So we need to get the x squared by itself. So we'll subtract 25 from both sides. And get x squared is equal to 64 minus 25 is 39. At which point we'll take the square root of both sides to cancel out that square. And get that x is equal to square root of 39, which is 6.244997 dot, 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 dot. And so we'll approximate it to 6.24. Any questions on that so far? So now we have that measurement. I'm going to replace x with what it is, which is 6.24. So in order to find out the total cost of this, this little remodel or like recarpeting, we need to find the area total so that we can multiply it by its price per square foot. So let's call this in 3 pieces. I'll call this piece 1, this piece 2, and this piece 3. The total area is equal to the area of piece 1 plus the area of piece 2 plus the area of piece 3. So area of piece 1 is a triangle. And the area formula for a triangle is 1/2 the base times the height. So this will be 1/2 the base, which is 6.24 times the height, which is 5. Area of piece 2, that's a rectangle, so that's going to be length times width. So 5 times 10. And the area of piece 3, John Doe student says, okay, it's going to be pi times 5 squared. Why is John Doe student wrong?
Only a quarter.
Yes,
By pi squared.
exactly right. Since this is only a quarter of a circle, we're only going to have a quarter of the area. So get the whole area of the circle and divide by 4. One-fourth in front. Because quarter circle. If it was a fifth of a circle, we divide by 5. If it was a third of a circle, we divide by 3, and so on and so forth. So let's just make sure we use the approximations. This is going to be, I'm going to rewrite it one more time so I can compute it all at the same time. So 5 times 10, and this is going to be plus 3.14 times 5 squared divided by 4. Let's plug that into our calculator. So 1/2 times 6.24 times 5 plus 50 plus 3.14 times 25, because that's 5 squared, divided by 4. And you get 85.225 square feet. Any questions on that? That's not the answer. The answer is going to be finding out the total cost of this recarpeting. So we need to figure out the cost in raw materials, and then we also need to figure out the labor costs. So raw materials cost you'll take that 85.225 feet squared, and this is going to be a unit conversion. Luckily for us, we'll need to do 1 unit conversion. So it's already given in feet squared. So it was $2.58, right? So $2.58 per square foot. So for every 1 foot squared, it's $2.58. Feet squareds cancel. And all we're left with, the only dimension that we are left with is dollars, which is exactly what we want. At the end of the day, we want to know how much it costs. So we should only have a dollar measurement at the end. So really, we're just going to be multiplying them together. So 85.225 times 2.58 is $219.8805. And we'll round to the nearest hundredth because that's what makes sense. Because cents, C-E-N-T-S, not S-E-N-S-C. That's a pretty funny joke. You guys should be laughing. No, I'm kidding. Thank you. So 219.88. That's the raw material cost. Now we need to talk about the labor cost. It said that it was $43.25 per hour, and they're estimating. So this is going to be like the estimate they're going to give you. So they're going to estimate it takes 5 hours. So we'll take that $43.25 and multiply it by 5 hours. This is a unit conversion, but I'm just going to do it quickly. This $43 per hour times 5 hours. The hours cancel. So 43.25 times 5 is $216.25. So total cost. Yes, we take those two numbers, add them together. $436.13. Any questions on that? And that is the answer because that's what we want. We want the total cost. There's a very, very cool book in mathematics education. I don't think I've talked about it yet, by George Polya. It's called How to Solve It. It's a textbook written by a mathematician, but he specializes in mathematics education. And his book was all about how to solve difficult math problems and like the procedure that you should follow along with techniques that you should do. And one of the things he always mentioned in his thing is like at the end of a problem, you should always reflect, not reflect on like why you're taking math 120, right? Not that, but reflect on the problem itself and make sure you've answered the question. That's what he meant by reflect. And so we should always do that with word problems is, did I answer the question at hand? So, all right. Number 4. So I should have mentioned this about the previous one. So this one right here is involving section 1.2 quadrilaterals. It's involving 1.4 because it's dealing with trigonometry, and then back to 1.2 for the area formula. This one was involving area and composite figures, so section 1.5, along with unit conversions 1.3, and then just some critical thinking to make sure you added in the cost of the labor. So, excuse me. I thought this one was pretty cute here. Question number 4. We're supposed to find the area and perimeter of this shape. So let's go ahead and fill in what we do know. Are there any sides that we know right off the bat that we can add? Yeah. So there's 3 unknown sides. This one. I'm going to do different colors actually. Not blue, I just used blue. So green and then pink. Do we know any of those sides? Yes, that's correct. because it's a rectangle.
Pink would be 3 as well.
That's right. What is that green side length? So, like, think about this for a second. Try to figure it out. Why would it be 2?
That's the point. I don't know, and it should be, even if it matches the other rectangle, it
So-
should be a 9,
Yes. So it's not.
or it should be 10. For matching the bottom of that rectangle.
I see. That would be an interesting way to do that. Is to slide them on top of each other. It's like the way I would think about doing it was if we can find out what this blue dimension is, then we could find out what this is because the blue plus the green has to be 9. So what is the dimension of the blue? 7 feet, because it's going to be 10 feet for the total thing minus the little side piece. 7 feet there, which means that the green is going to be 9 minus 7, so 2 feet. Is that okay? It's a tricky one. I thought that was cute.
The way you talk about math is being cute. indicates-
It's cute. It's cute problem. It's very, very, like fun. Thanks. Is that only mathematicians? That's true. That's true. I remember talking, to go off on a little tangent. So, the definition, so in calculus, there's the definition of a limit. And like, you don't need to write this down. This is ridiculous, but it's, you say that the limit as x approaches a of f of x is equal to L if for all epsilon greater than 0, there exists a delta greater than 0 such that absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is less than delta. Very, very confusing definition. Incredibly confusing, especially for a first-year math student, math major. And it's not English. I would have agreed with you about how long ago was that? 12, 14 years ago. I would have agreed with you. And I brought this up to my teacher. I was like, I hate this definition. It's like, oh no, it's beautiful. And it took me going into grad school to finally understand why it was so beautiful, because it's very, very precise. There's not a wasted word there. Mathematicians love to try and use as little words to describe things as possible because we don't like to write. Go figure. We're mathematicians, not English people. But anyways, I digress. So we got everything we need then. We got all the dimensions needed. The area we could have found without finding those dimensions, but we needed them for the perimeter, right? So perimeter, he's just going to be adding up all the side lengths. I'm going to start with the 3 here and move my way along. So there's 1, 2, 3, 4, 5, 6, 7, 8 sides. So I should have 8 numbers when I add these things all up. So 3 plus 3 plus 4.5 plus 9 plus 4.5 plus 2 plus 3 plus 10. Is that 8 numbers? 1, 2, 3, 4, 5, 6, 7, 8. Very, very good. You can also do it by like checking off each side length that you do. I know you're like, Phil, that's stupid. I don't need to do that. I know what I'm doing. And the answer is you probably do know what you're doing, but you can't account for everybody. Maybe you get, what do they call that? It was an awful thing. They would find streamers' houses and then they call SWAT on them. Swatting? Is that what it was? Swatting, yeah.
It's like when someone makes a fake emergency.
See, and then they bust through your door. So maybe you're taking this exam and then someone swatted you, boom, and you forgot to mark out, you forgot how many sides you added up. So boom. That's that's the exact situation you'll run into. Hopefully nobody does.
What an analogy.
Yeah, exactly. Man, I still think about that. That's such a rude thing. You're just now you have to spend your time to repair your door. Like they're destroying your money with your money. I had to fix it. But anyways, I'm getting sidetracked. 3 plus 3 plus 4.5 plus 9 plus 4.5 plus 2 plus 3 plus 10 should be 39. 39 feet. And the area you can do it a lot of different ways, but the quickest way would be to find the area of this rectangle and this rectangle, like the top and the bottom rectangles. So the area is going to be, I'm going to call this piece 1 and this piece 2. Doesn't matter which one I did first, but it's going to be the area of piece 1 plus the area of piece 2. So area of 1 would be 3 times 10. And the area of 2 would be 9 times 4.5. So 30 plus 9 times 4.5 is 70.5 feet squared. Any questions on that? Good news is that this is mainly just 1.4. This is, sorry, 1.5 with composite figures. But you still have to find area and perimeter, which were defined in 1.2. So. All right, we'll do number 5. I thought number 5 was pretty fun. A party tablecloth is being placed onto it should say party tablecloths are being placed, not a party, like that wouldn't make any sense. So 4 party tablecloths are being placed on 4 rectangular tables, each measuring 4 feet wide and 10 feet long. The tablecloth has a drape, so when you put it over it, it kind of drapes over the sides such that there's 2.5 feet that drapes over. You intend to add some fun, frilly stuff for this party at the very bottom of those things. Yes.
No, I got the perimeter of the last 5 sitting wrong. I keep getting 120.
You're getting 120. Are you multiplying or adding? Okay.
There's no way. Oh, maybe I am multiplying.
It could be that you accidentally multiplied at one point. Like they're right next to each other. Easy finger slip could cause chaos. So you're adding some frilly stuff to the bottom of them on the edges, on the whole border of the tablecloth to make it look fun. I couldn't think of anything better to say than just some fun, frilly stuff. So you intend to add some fun, frilly stuff to all 4 the edges of all 4 tablecloths. How much frilly stuff will you need? How many feet of frilly stuff? So we got this cool table, right? And then we got we got a tablecloth that kind of drapes over the side. I can't draw a tablecloth to save my life. So it drapes over 2.5 feet on everywhere. So that means that you have the original rectangle plus 2.5 in every dimension. Does that make sense? So here's the to draw a new picture. You have your table. This is the table. And it's measuring, what was it? 4 feet by 10 feet. So 4 feet by 10 feet. And then the drape adds an additional 2.5 everywhere. So there's an additional 2.5 feet here and 2.5 feet here. So first off, we need to know And we're trying to add some frilly stuff at the end. So the frilly stuff along the border. So the frilly stuff. So what are we trying to find? The area, the perimeter, because it's on the border of this thing. Like we could find the area, but it's not going to be useful to us. So we just need to find the perimeter of each rectangle and then multiply by 4 because there's 4 tables. So this distance would be what? John Doe student says 12.5. Why is John Doe student wrong? Forgot the other side. That's silly John Doe. He's a big dummy. You got to also measure this side length is 2.5 as well. So you've got 10 from the table plus an additional 2.5 on each side, so an additional 5. So this is 15. And similarly, this will be 9 feet. So perimeter of one table. So one table will be 9 plus 15 plus 9 plus 15. You can do that formula 2 times the length plus 2 times the width if you want to, but you don't have to memorize that formula. Just add it up this way. That's going to be 30 plus 18, so 48 feet. And so total amount 4 times that 48. Because we need to do this for all 4 tables. 4 times 48 is 192 feet of frilly stuff. The next question. I greatly enjoyed creating the next question. All right, any questions on this one? So this one is primarily 1.2, but with a little bit of spatial reasoning added on top. So question 6, though. You plan on filling a bathtub to the brim with champagne so you can feel like you know, typical Vegas stuff, right? And so you're gonna fill it not just with like Cooks, you know, like we could just go with Cooks and say that we did it with everything, but no, we're gonna go real hard. We're gonna do Dom Perignon, which is for a 7.5 liter bottle. It's $279.99 apparently at Target. I didn't look up online. I didn't go to a Target just to find that out. But that is way too old. That is ridiculous. That is obscene. And I bet you it tastes just the same. Has anybody had Dom Perignon?
No.
I've never. It's a very, very fancy champagne. Like the most I've had is pretty much just Cooks.
Yeah.
So, but I forgot to mention, so the bathtub is a half cylinder. So it kind of looks like a trough. So we've got kind of this shape. Like that shape right there. You see what I'm saying? Like I can't draw it very well, but it's like you cut a cylinder directly in half. So this dimension right here, the height of the cylinder, which would be the length or the width of it, but because it's on a side, but just so we're consistent with the knowledge, with the language, that's 6.5 feet, and then it has a radius of 3 feet. So how much will this bath of pure champagne cost? Here, I'm actually just going to dump down the drain. So You're gonna need to use, so when we do measurements, when we do these measurements, the problem is when you're doing volume measurements, it starts off as a cubic measurement of dimension. So like length or width, like length, width, and height stuff. So it's gonna be feet cubed, but we don't measure our liquids in feet cubed. We measure them in milliliters or liters and stuff. So we're gonna use the fact that 1 foot cubed is actually 28.316 liters. That's gonna be very, very useful to us. So first things first, we need to know how much, like the volume. So the volume, classic John Doe. So the formula for the air, the volume of a cylinder is pi squared RH, right? Pi squared, pi r squared H, right? But classic John Doe student does this. Why is he wrong? This isn't a full cylinder. This is a half of a cylinder. So divided by 2 because half cylinder. So this is going to be 3.14 times r squared, which is 3, times the height, which is 6.5, all divided by 2. Plugging that into my calculator, I get 3.14 times 9 times 6.5. Divide that by 2. 91.845. And I'm not going to round it. I could round it to 91.85. But we can keep it like this. So that's feet cubed. Any questions on that? All right. So then we need to convert this to liters, and then we can convert the liters to dollars by the fact that it's one bottle, like 0.75 liters of Dom Perignon is $279.99. Like when you're that expensive, do you really need to be playing the 99 cents trick in advertising? Okay. So 91.845 feet cubed. We're going to use the first trick, which is to convert the feet cubed into liters. 1 cubic foot, so 1 foot cubed is equal to 28.316 liters. Now we'll cancel the feet cubed. And then we know that for every bottle of Dom Perignon, it's which is 0.75 liters, it costs $279. That's going to be our next conversion factor. The liters should go on the bottom, so 0.75 liters is $279.99. The liters cancel. And we're left with dollars, which is exactly what we want. So this is going to be quite an expensive bath. 91.845 times 28.316 times 279.99 divided by 0.75. When you divide by a number smaller than 1, the whole thing gets larger too. So this is going to be quite a large number. 91.845 times 28.316 times 279.99. 0.75. It is $970,886.99. I mean, it kind of makes sense if you think about it. Like, imagine your average bathtub, and like imagine like a 0.75 liter, like, which I believe that's a handle, correct? 0.75 liters. Yeah.
Yeah.
700. So it originally, like when it was listed online, it said 750 milliliters, but I didn't want to make us do another unit conversion. So that's why I converted to 0.75 liters. So 0.75 liters, that's like a handle of alcohol, as they say. So imagine how many bottles it would take.
Right. So the full amount.
So that's $1 million bath right there. Now, granted, technically speaking, you'd have to take into account the fact that you have your volume would displace some of it. So you wouldn't have to do exactly 900, maybe only 900,000. So that's not bad, you know?
But what's the 70,000 if you already are spending 900,000 on it?
True, very, very true. So, any questions on that one? I thought that was pretty fun. Like, now the next question will be, how much would it be in cooks? It's like $13 a bottle. Okay, so that's number 6, right? And so this one was involving unit conversions. It was involving 1.6, so volume measurements of a cylinder. Didn't do anything about area. Maybe I could have added something on here like you're gonna make sure you gold plate the area, the surface area of it, but okay, so the last one. I'm doing good on time. So can I copy this? I don't know if I can because I didn't hand draw that one. Can I copy you? No way. Will it let me? Nice. Okay. So we're supposed to find the measurements of side BE and side DE, knowing the two triangles are similar. So what we need to do, and this is one of those ones, so this is similar triangles, so there's proportional relationships here, right? This is section 1.3, the beginning of it. Section 1.3 had triangles basics, which included similar triangles, and then it also included unit conversions. So I always like to color code my triangles. So the longest side, that would be the hypotenuse. Let's go ahead, color code them. Then what side should correspond to AC? ED, yeah, DE, ED, whatever you want to call it. And then that means by process of elimination, this is the last one. So let's label the, no. Let's label them X and Y or whatever we want to call them. X and Y. So we don't need to use trig here. You only need to use trig when you have an angle. We don't have an angle here. I mean, we do have right triangles, so we do have the 90-degree angle, but we don't know the other angles. And so we just need to set up proportional relationships.
And so I'm just curious because I missed that day, right? Like that, so if just given the 90-degree angle, could I technically with SOHCAHTOA or trig find the other? No, right?
So yes and no. Yes, you could, but you have to do something that we haven't talked about and,
Okay.
and we didn't like. You notice, and this is a good thing to talk about. Sine of theta, sine of an angle A, you don't need to write this, is opposite over hypotenuse, right? So if you have the opposite and the hypotenuse, which we would in triangle ABC, then you have everything, but you don't have angle A. There's a symbol in your calculator called sine inverse. It's a sign with a -1 for an exponent. That allows you to find angles given the two side lengths, which we didn't go over, but you can use it. And that would allow you to find the angles, which would allow you to find, yes. So, but we're just going to use similar triangles. So I'm going to do small red over big red is equal to, which side should I use to solve this? Should I use green or blue? Take a second, don't answer it out loud, let everyone get a chance to think. Which side, which color?
Great.
Green, blue,
Oh, it's also very.
it also has a variable. If we found Y already, then we could use it, but green is going to be the one that we know the angles, the dimensions already. So we're going to do small green over big green. I don't know why I capitalized that one R. So X,
Capitalize the P. Oh, never mind.
I could, I agree with you. This could be a lowercase s. This could be a lowercase s. So X over 20 is equal to small green, which is 12 over big green, which is 16. And then we cross multiply. 16x is equal to 20 times 12, which is 240. Divide by 16. And then to solve for x, we need to divide by 16. And get that x is equal to 15 feet or 15 meters. Those are right. Come on. You go. Now, we could find y by using the Pythagorean theorem now, because we have two, like it's a right triangle. And so we could find it that way, but we might as well just keep using similar triangles. So we'll do small blue over big blue is equal to small green over big green. Granted, now that we know what the red side is, we could do small red over big red. We could do that too. But small blue is y over big blue, which is 12, is equal to 12 over 16. Cross multiply. 16y is equal to 144. And once again, we have to cancel out the 16. So we divide both sides by 16. And get 9. Y is equal to 9 meters. Any questions on those? The only thing I kind of wanted to do, the creative juices weren't flowing enough to figure out how to do like a similar triangle problem that involved area. So bonus question. What is the area of that shape? So we have to do two triangles. So you have to do 1/2 the base times the height for both of them. So I'll call this triangle 1 and triangle 2. So the area of the total will equal area of triangle 1 plus the area of triangle 2. 1/2 the base is 16 times the height, which is 12, plus the next one, 1/2 the base, which was 12, times the height, which is 9. Yes, that's not really technically the base because it's not in the right orientation, but all you need to do is flip the shape upwards, reflect it, and you'll see it. So that should be 8 times 12 plus 6 times 9, 150 meters squared. Any questions on that? On these concepts as a whole? So those are the only problems I had for today. If you guys have any, like, does anybody else have any things that they want to go over from chapter 1? Yes.
You have a good question with like the tree in the river.
The tree in the river?
We could do something with that.
Sure. So it's, oh God, I can't remember exactly what I was saying. We can do one of those ones.
About, like, the
Oh, the angle of elevation stuff.
right?
Okay.
And then calculating how wide the river was from.
Yeah.
Yes, that's right. Okay. It told you the height of the tree, correct? Yes. Okay.
And then the degree.
Yes. So
Wanted to figure out how long the wide the river.
that's right. So here's a river, and then here's our little dude on the land. And it says the angle of elevation. So when you see this problem, it says the angle of elevation from the observer's shoes from flat ground. And that's because they want to simplify it. It makes it more complicated, but at the same time, it makes it less complicated. It makes the verbiage more complicated, but the mathematics less complicated. Because if I said the angle of elevation from the observer, that would be talking about the dude's eyes.
Okay, see, so I think that's where I went wrong. I didn't see elevation, or the angle of elevation from his shoes. So I was trying to figure out how the hell I'm gonna figure that out. If he's seeing the mid-tree, if he looks straight forward.
Exactly. So that's the thing. So the angle, like if it had said the angle of elevation from the observer, then that would be from the person's eyes. But it's saying from his feet. So what we've got instead is we've got this situation going on. Like that. And it's, let's say the angle of elevation, they said was 44 degrees. Or 47 degrees, why not? And they say that the tree is 35 feet tall. How wide is the river? This becomes not too bad once you know that little piece of verbiage that can be very, very confusing. So does everyone see what I mean by being like the language becomes more complex, but it actually makes the problem mathematically simpler? Because imagine if I had instead done it with copy this. If I instead done this with the person's height, in order to like figure out the distance here, we'd have to take the whole tree's length and subtract off the height of the man or woman or person, whatever it is.
And
So-
so would give you the explanation about the.
It would have had to tell you how tall the person was.
Okay, got it.
So that would be the missing piece of information. That's the reason why they phrased it as such. So we want to know the length or the width of the river. So we got an angle measurement. Like once you see an angle measurement, your mind should immediately be thinking trigonometry. Should think in that SOHCAHTOA. Which one should I use? Which trig function should I use? Don't answer it. Let them get a chance to think. Honestly, the way I figure it out, like now I know exactly which one to use just by looking at it because I've been doing this for so long. But when I first started, it was like, what side do I want and what side do I have? So I have the opposite side and I want the adjacent side. So which one should I use? Tangent. Now, if I had both, if I had the hypotenuse as well, if I had the pink dashed line, I could use cosine as well. But as it stands, I want to, I'm gonna use tangent. So tangent's the right call. So tangent of 47 degrees is equal to opposite over adjacent, so that's 35 over x. Tangent of 47 degrees is 1.07236, or so roughly 1.0724 is equal to 35 over x. Gonna solve for this. So the x is in the denominator. So this becomes a two-step process. So we need to multiply, like if we're gonna do cross multiplication, we're gonna get now we have 1.0724x is equal to 35, and we need to divide both sides by that 1.0724 in order to get x. Get that x is equal to, so 35 divided by 1.0724. You get 32.6370 on and on forever. So if we're gonna round to the nearest 100th, 32.64 feet. Any questions on that? So yeah, the angle of elevation has to do with the like whatever is being like the thing that is observing. It's a straight line out from them, and the angle of elevation will be going up. Angle of depression will be going down. Okay. So I guess unless there's any other questions, happy to answer any other ones that people have. Okay then. So we will start up on Wednesday with chapter 2. Keep in mind your homework for this week is to do section 2.1 as well. That's like the history of chapter 2, all the fun little biography section. For the quiz, for the exam, by the way, there's no history questions on there. You don't need to study section 2.1 or 1.1. You don't need to, there's not gonna be anything like that on there. So it's purely math, like 1.2 to 1.6. 3 attempts at it. Please feel free to email me any questions that you have. Like you can say like, hey, I got question 5 wrong. Can you tell me how? And I'm happy to answer those questions. Okay, guys? Otherwise, you guys have a great rest of your day. Good luck on the exam if you take it now. Otherwise, remember, you have to take it by Friday. And I will see you guys on Wednesday, all right? Have a good one.